The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Thanks for joining us today. We'll get started here momentarily. While we're waiting for some more people to join in, please go ahead and check out. And we want to give thanks to a couple of our indoor specialty partners, Blue Raster and GIS Inc. Another minute or so and we'll get started. Actually, I could see some questions have already come in. That's awesome. Hopefully, these should be answered in the content of the presentation. All right, it's 1 after the hour. Let's go ahead and get started here.
All right, thank you, Christian. Let's start. So, hi everyone, and welcome to our webinar on the steps to successfully implement ArcGIS Indoors in your organization. This webinar is part of a series of webinars on ArcGIS Indoors we've been holding over the year, and some more are going to follow in the next couple of months, so do stay tuned for those as well. Throughout this webinar, we're going to launch a couple of polls so we can get to know you a little bit better. They should pop up on your screen and they're all multiple choice, so it's just 1 or 2 clicks if you want to participate. This session will also be recorded and the link to the video will be sent out to everyone after the webinar, so you can watch it again at your convenience. Yeah, so let's introduce ourselves. My name is Sylvia Pichler. I am a Senior Marketing Specialist at the SV R&D Center in Vienna, Austria. And with me today are Patrick Wallis, the Indoors and Facilities Practice Lead from ArcGIS Indoors, Max Spilkelis, our Senior Consultant at the R&D Center in Vienna, and Christian Tate, the Marketing Specialist for ArcGIS Indoors. So what can you expect from this webinar today? First, we're going to give you a little bit of an overview on how ArcGIS Indoors can be used and why you need it. Then Pat is going to dive into the technical details of how the system is implemented, and he's also going to give you a short demo. Then Max will give you some insights into the indoor positioning capability and how you can deploy it. And we've also established an indoors pilot program, which we wanted to highlight. So we're going to introduce that to you as well, and I think Pat is going to tell you a little bit more about that towards the end of the webinar. And as Christian already mentioned, at the very end of the webinar, we're also planning for a short Q&A. So if you have any questions, please submit them via the webinar panel, and we'll try to answer as many of them as possible in the time that we have. All right, so without further ado, I'd say let's jump right in. So why do you actually need ArcGIS Indoors? Excuse me. So today, 2 out of 3 buildings still do not have any common operating data. These companies are mostly relying on pen and paper reports or other data sources such as Excel, email, or CAD. This lack of interoperable data leads to highly inefficient processes and costs owners and operators up to $0.33 US per square feet per year. Now, if you extrapolate that to a huge building complex, such as corporate campuses, this can result in a horrendous amount of money lost. So let's take a little bit longer with the example of corporate campuses. Managing big office complexes efficiently is a major challenge, and ArcGIS Indoors is providing the means to tackle these head-on and create a smart workplace. So what ArcGIS Indoors does is it visualizes places, people, and objects on a digital workplace map. And since all workflows are connected to location, everything is digitally enabled. This means insights into all operations going on inside the building an easy understanding of workflows, people, and assets in a location context, and data visualization that provides a clear overview on a dashboard. That way, all employees are presented with a common operating picture that gives them the level of insight they need to perform their tasks best. What is also really important is that all employees are informed about the accessibility, availability, and condition of office resources at all times. That way, the right resources can be allocated to wherever they are needed the most at the right time. In addition, you can be more proactive about your work order management and react faster to maintenance requests. Employees walking around the campus may notice, if an asset, for instance, a screen in a conference room is broken. They can then use the mobile phone to mark the location on the workplace map and report the issue to the technical department. The tech department can then react instantly to repair it and ensure that meetings can be held with fully functional equipment again. And I think we all agree that good collaboration and teamwork are essential for a company's success. So whether it is employees sharing their own real-time location with colleagues for an ad hoc face-to-face meeting, or like we just talked about, employees helping the office stay fully functional by reporting issues to the tech department via the workplace map, a connected workforce can really make a big difference. ArcGIS Indoors can also be used to enhance your security operations. So you can, for instance, analyze indoor spatial data such as foot traffic patterns to avoid congestions and improve space management. Or you could also look at the data to place emergency equipment such as fire extinguishers strategically throughout the buildings for ease of accessibility. So all in all, with ArcGIS Indoors, you can see all of facilities and spaces inside and out in a single location, the workplace map. By seeing your assets, inventories, and spaces assignments in the context of a map, you can make more informed decisions for optimizing your operations. So these are just a few of the many use cases of ArcGIS Indoors, but they should give you a rough idea of how you can leverage it to optimize your very own workplace operations. And with that, I would actually like to launch our first poll, or actually Christian is going to launch it, and we want to know from you, what is your primary source of building data?
Okay, the poll is now open. Go ahead and take a moment to select one of these. Give everyone enough time to answer. Give about 10 more seconds here. Okay, the majority of you have answered, so we'll go ahead and close this and share our results. And good mix here. A lot of us have DWG files, quite a few PDFs, and also CAD drawings, so it's good to see.
A great mix. Okay, interesting. Thank you everyone for participating. And with that, I would like to hand it over to Pat. And thanks, Christian.
Yep. Thank you, Sylvia. If you didn't catch it, ArcGIS Indoors is a complete geo-enabled system for assembling, managing, and sharing workplace location information for a range of stakeholders, business owners to employees to visitors, for a whole range of use cases. Again, it's not a single application, but a complete system that includes ArcGIS Pro data creation and curation capabilities, the WebGIS capabilities of ArcGIS Enterprise, also web and native mobile applications, and off-the-shelf integration points with third-party systems like ServiceNow and CityWorks. As Sylvia was getting at earlier, in order to start implementing Indoors, you'll need a business justification to invest in the system. This is the real first step. You'll need to identify the relevant pain points. You need to speak your organization's or your customer's language and understand the processes involved. And you need to define goals together. Once you've done this, you'll be able to pinpoint what the key drivers and related return on investment would be for your organization or your customer's organization. Typical drivers are going to be to improve service delivery times, this core need for a common operating picture that would work across the workplace, as well as the ability to monitor continuity. These are common problems where location intelligence makes a real difference. And if you haven't already read it, please download this white paper, Winning with Location Intelligence. It was written by Esri Canada, and so use it to drive those ROI discussions. Okay, it's time for another poll. The question this time is, what would you like to use ArcGIS Indoors for? Again, what would you like to use ArcGIS Indoors for? Is it wayfinding, operations management, asset management, portfolio management, security, or some other use case? Go ahead and take a second to answer the questions.
And please select all that apply for this one. This is not just a one and done. Wait about 30 more seconds here, give everyone a chance to answer. All right, looks like we got a majority here. Let's go ahead and close that and share our results. So over 50% answered wayfinding, operations management, and asset management. And also a decent chunk on portfolio and other as well, but over 50% for those first three.
Okay, great. Well, let's move on. Next, I have a couple of demos before we get into the following steps to implement ArcGIS Indoors. And so in this first demonstration, we have the mobile application. I'm using an iOS device. I recorded this earlier. And I'm just walking down the hall towards my office. We had implemented BLE, Bluetooth Low Energy, Wi-Fi based, I mean, not Wi-Fi, but based indoor positioning. And now I get out of the compass mode and I'm taking a look at my calendar, the integration with our calendar, and I can find where this upcoming meeting is. I can route to it. For example, I can look at any upcoming events. We only have one that day, and that would be at the cafe. I can also interrogate the map, find out more information, like where's the closest print room. So if I didn't know, I'd find out pretty quickly. It's really just around the corner from my office. But I'm really looking for a conference room. So I'm going to go look under places and things and conference rooms, and I'll see that the results are sorted by proximity to my current location. That conference room is too small, but it is really close. It's just not going to work for the meeting I have in mind. So I'm going to go back to my list and I'm going to search for the ADC, which is on the first floor, much larger. It'll meet my need. I can see the floor where directions will bring me to that location. I can share this with a colleague that I want to meet at that conference room. I'm just going to use my name in this example so I can send it to myself. They'll get the hot link and they can open it up in their app. But let's say I get there and something's awry. I can submit a service request that just sucks in all the location intelligence and pushes it to that web form. Now in this next demonstration, I have a video of our web application. You'll see a lot of the same functionality. And in this one, my identity is loaded. Because my identity is known, it drives to my home location. It sees it as Pat Wallace. I can pull up relevant attributes for that location, see any related items, and dive into that information. But maybe I just want to search for a colleague like my buddy Christian, so I'll just type in his name, and it's going to drive me to his location and building M. It's a pretty crazy building. Even folks that have worked here for a while get lost in that building. So I'll plug in the directions here and it'll deliver landmark-based directions. So you can see the results here. And I could change it to an accessible route and it would change from going up the stairs to an elevator as well. It also has the Explore functionality, just like in the mobile application. These are all sorted by proximity from my home location. And we can see here, I'll dive into the collaboration space just next to my office. Again, we can see events in the web application, just like in the mobile application. If you're like a university or a corporate campus, you may have a bunch of training events that are available, or speaker engagement, so you can see that here. This is our kiosk version of the app, so it's essentially the same app. It's just a different form factor, and imagine this on a big touch screen. You have the big buttons that you can touch, and just take a second to understand some of the differences. So the main difference is that it has a "you are here" marker, so all the directions are going to be driven from that location, right? So that's what you would expect. And so you could imagine using this in the lobbies of your main buildings, or in the digital signage program as part of your organization. So those are a couple short demos just to get you thinking about how the indoors applications work and work together. But first steps first, or rather the second step, right? The first one is we figured out why we're going to use indoors. The second step is deploying a base deployment of ArcGIS Enterprise. That's the engine that powers indoors. So we'd recommend separate servers for the portal instance, your ArcGIS server, and data stores. Of course, you're going to need to size the cores, RAM, and storage appropriately. Don't just put it on one box. It's not going to be a demo machine. Indoors web requires Microsoft IIS. So for you Linux fans out there, it's not certified yet. I have seen it working on Linux, so I'd expect that to be coming shortly. We do support most web browsers, except for IE11, which of course would be deprecated in January. Now, a base deployment of Enterprise for Indoors provides the following: the Indoors web and other configurable app templates. It would authenticate the use of the mobile app, as well as host the maps that the mobile application consumes. It provides the location tracking service and track viewer web app that are part of device tracking capabilities for indoors. It would provide Survey 123 for submitting service requests, the web app builder and dashboard for creating custom applications for analytics and other business purposes that run on top of indoor maps, as well as the full suite of Esri apps and custom built apps that one could build from our JavaScript API and runtime SDKs. In fact, we're putting a number of sample code projects on GitHub. Here's an example for our floor picker. Now, if you didn't know it, Enterprise is a product that is built on 4 primary components: web adapter, portal for ArcGIS, including the ArcGIS license server, ArcGIS server itself, as well as any needed data stores. One of the first things you'll do once you have Portal stood up is to import your licenses to enable ArcGIS indoors and provide that organizational capability. Once you've done that, it should look like what you see here in the screenshot. The next step would be to set up access for Pro on the Portal instance. So install the license server, make sure you have the right user types assigned to your organization who would access Pro. Assign them at a minimum to the publisher role, and then when they use it, they need to authenticate Pro with this licensing server for a licensing portal for indoors, rather. Because with the indoors applications, you'll be zooming in pretty close to the Earth's surface to the scale of a room and below, right? You're going to probably need different base maps than what's provided with the Esri hosted base maps. So typically, our customers would create their own custom vector tile maps. So create your own base maps group, share that to the organization, and set that as a default base map gallery. Then you can access those custom base maps from your indoors applications. Another lesson learned is that typically organizations are going to set up a different look and feel for versions of the indoors app for different business units in their org. So create an indoors configurable applications group, share that to your organization. You're going to need to go to the portal settings and update some settings for maps and groups, pointing them to the indoors configurable applications group. One of the other things you'll need to do in Portal is to enable device tracking is to turn on location tracking for the portal. That uses the ArcGIS location tracking service. It's pretty simple. You just click a button, and if you have the big data store connected as a data store, you can turn it on. Once you've done that in the mobile application, you can find the current location for any team member that's participating in the device tracking service and functionality. Okay, it's time for another poll. And the question this time is, do you have any experience using ArcGIS Pro to curate workplace data? Again, do you have any experience using ArcGIS Pro to curate workplace data?
All right, the poll is open. Go ahead and select one, yes or no. Give a few more seconds here for everyone to get a chance to answer. Okay, let's go ahead and close this and share our results. So roughly 70% said no, which we kind of expected that, and that's why we're here today. So.
Okay, great. Well, let's dive into it and get you a little bit more familiar with the tools that are available. So this next section, conveniently, is creating and curating data with Indoors for Pro. So with the tools for Pro, you're going to be able to load in your engineering drawings into the Indoors model, create relevant points of interest. That's what you saw in the Explore panel, and the applications generate a routable network for your workplace and create maps and share them to your organization for use in the Indoors apps. One of the first things you need to do is install the software, right? So there's a installer for the toolbox. There's an installer for sample product files. Once you've installed these applications, you need to set up licensing in ArcGIS Pro. Point it to your licensing portal, update the Python environment for the Indoors Python environment, and of course, sign in to your portal. The tools that are included in the toolbox include the ability to create an Indoors database with the Indoors information model in it, the floor plan to Indoors tool, which will suck in your CAD data, push it into that database, create points of interest representing your people, also create the Indoors network from your points of interest and your converted floor plan data, and then the ability to turn on your indoor positioning. One of the first questions, though, is are my engineering drawings fit for purpose in ArcGIS Indoors? So, and this is relevant for CAD or BIM data. You'll have these questions available after the presentation, but in general, right, do they have architectural features? Are the features connected? Do you have doors, windows, walls, stairs, for example? Is the annotation legible? Is it intelligible? Will it provide meaning to the resulting Indoors data? If it doesn't, you may have work to do back in your source CAD or BIM data. Once you made that determination, and let's say the answer is yes, you need to georeference your CAD data in Pro, both horizontally and vertically aligning between levels. Here you can use the off-the-shelf georeferencing tools with ArcGIS Pro. Once you've taken that step, you can create the Indoors database, right? And that'll create all the needed indoor features, the core campus type data features like buildings and spaces and detail lines, as well as network features like paths and landmarks, and device tracking features like track zones and dead zones, and some configuration tables. Once you've created the database, we're ready to pour your engineering drawing data into it. And that'll point to, it'll pull in an Excel worksheet where you map between the CAD layers that you have and the output GIS features that you want. It'll grab the location of your Indoors database as well as the location of your engineering drawings and push that out to your Indoors database. And once you have the result, you'll inspect it for errors and gaps spatially and as well as in the attribution and you'll need to update, you know, the elevation or Z values too for the output data. Next, we're ready to create points of interest. You know, what are they? There are people, places, events, or other objects. They're what you want to find on a map. They're also used to create your network data set, and they facilitate searching in our applications. And they're grouped into two categories, broad level 1 and a more refined level 2 category, as what you see here depicted in the screenshots. Typically, they're made from your source engineering drawings that have been converted, like from your building outlines, your rooms, let's say your conference rooms, you want to find that, for example. You know, again, these two categories, you know, these are the ones that come with the application. They're totally customizable, though. They can be whatever you want them to be. These are just a starting point for you. Then, if you have people that you want to represent in the application to facilitate finding colleagues, you can use the Create People Points tool, and that'll create that point of interest for your people. Also, you can use a similar workflow to create events. These are time-enabled points of interest, so you can see your organization's events and then load them into your own calendar. Now, if they're not in the data, the source data that you have, you may need to manually create points of interest for things like water fountains, vending machines, fire extinguishers that may have a line in the source CAD file but no annotation, right? So you're going to need to manually create that. Similarly, for site scale features like you know, landmarks that are commonly known for that workplace, fountains or art pieces like that, you have to manually create that. If you manually create them, just make sure that the attribution is correct and they do have an elevation value, because that's what's going to snap it to the network data set that we'll create later. You'll need to create a point of interest for kiosks, for example. So you want that "You Are Here" symbol to show up in the right place. So that would be an example of manually creating a point of interest. Also, you'll need to create boundaries for track zones. It's simple. You just update one attribute, track type, if you want to enable device tracking. If you don't have it, device tracking will not be available for those users with that map. Then there are some configuration tables. A lot of the configuration is in the hands of the map maker. Two are being deprecated. I'm not going to talk about those, so I'll focus on the categories table and the indoors config table. Categories is what drives the exploration panel. Again, like I said, it's totally customizable. You can change the icons if you don't like them, add to them if you like them. You can change the level 1 and level 2 as seen here in these screenshots. The config table contains some mandatory and some optional fields like your portal URL. If you want a link to a service request, you can plug in the 311 URL there. Enter your time zone from UTC, and then if you have device tracking, there's a number of parameters you can update here. Next, we're ready to create the network, because you create that from your core indoor features as well as your points of interest. So first, you will generate a dense lattice, and then we'll create transitions connecting the lattice between different floors. Then we'll thin the lattice out with the Thin Pathways tool, and using the Classify Pathways tool, we can optimize the routing result, and then we're ready to generate the final network. At this point, everyone, we're ready to create some maps for use in our indoors applications. So using the product data files that we loaded earlier, we can load the indoor styles into our ArcGIS Pro project and apply those styles to our map. Now, if you want to add to it, add to it. If you want to change them all together, you would change them using the style management tools in Pro. Once you've created a map that makes sense for your organization or a series of maps, you can publish them as web maps and mobile maps using the default publishing capabilities of ArcGIS Pro to your indoors portal. Optionally, at this point, you could create 3D data for indoors if you didn't already have it in your source BIM. you can create beautiful 3D data from your 2D like this, just using 4 feature classes: details, units, levels, and facilities. And it would create the output features that you can use in a 3D scene for the indoors web application. Now, setting up the indoors web application, there's a few steps you'll need to take, and I'm going to go over those here. As I mentioned earlier, it does come with Enterprise, right? You have a default configurable app that you could, take any indoors web map, push it out as an indoors web application. But typically, you're going to want to make copies of it, style them differently. So here's an example. Like on the portal instance, you'd make a copy of the default indoors, name it something intelligible, add that as a new item to your portal, a configurable JavaScript web application. You'd paste in the configuration parameters that are part of the indoors documentation. And then you would go to that folder, and you'd use an editor, an IDE editor, to update the JSON configuration settings. In the future, this will all be in the configurator for the application, but right now it's in a JSON file. So you could update things like the selection color for when you select a building. You could update what the icon looks like for some of the related items, for example, in an indoors application. You can also brand the app using the theme.css file, so you can update the icon, update all the colors. The team has done a really great job in compacting, what can be updatable in the CSS theme file. And so if you have a modern IDE, we recommend using that to just update the style file, for example, because it's really easy. You'll see the colors, you can update them directly. The doc is really great on this. I recommend you take a look at it. At this point, right, you have your apps registered, and now you can share any of your web maps to any of these configurable applications that you set up. So if you have a web map, you can create the Create Web Application button using a template, and then you can preview it directly in the configurator and update the configuration, the parameters directly in Portal. So super easy. But mobile's even easier. You just go to the Apple App Store and download the iOS app, and you go to the Google Play Store and you download the app for Android devices. And one last thing I want to go over is the configurable 311 that works on both mobile and web. In the first release, it only worked with Survey 1, 2, 3. And as long as you had the building, floor, wing, and room fields in your Survey 1, 2, 3 form, it would populate data from your indoor map directly into the form. You could add other things like to the survey, like X, Y, and Z for post-processing purposes, but it's pretty straightforward. In subsequent releases, we've provided more capability using standard HTTP syntax. You can load whatever data you want from the indoor map from whatever layer into that web form. And here's just a screenshot showing how you might do that. And with that, we're ready to go over IPS fundamentals with Max.
All right, thanks, Pat. So everybody should be able to see my screen. I'm just going to go over some brief underlying principles at first before digging a little deeper into how an IPS works. IPS stands for Indoor Positioning System. And yeah, why do you want one? I think in the first poll, we already had a pretty good indicator. A lot of you want to use wayfinding. And obviously, it's especially when you're on a mobile, it's nice to have your current position for wayfinding. So if you want to do live navigation or tracking of things, you will need an IPS to get the location. Also, with historic data, you can run in-depth analytics of user movement, user behavior, and basically whatever you want to track and analyze. And we need an IPS for that because GPS is indoors very often inaccurate or sometimes completely unavailable. But even if it is available, it has one major flaw, and GPS does not provide floor level information, which is kind of crucial when you want to navigate in a building, because many buildings have more than just one floor. And when we're talking about IPS here in this context, we're usually talking about a radio-based IPS. That means that we're using some source of radio signals. In most cases, that's going to be Wi-Fi or Bluetooth, and calculate a position based on those signals. In any case, you will start with a map, and then you enrich that map in a database with something. So the easiest way would be to put some transmitters throughout your venue or throughout your building, annotate them in a database. And the principle behind that is, once you come close to one of those transmitters, the device will recognize it by comparing it to the database, see, aha, I received this transmitter is here, so I must be here too. That's the very simple concept behind it. Now, you maybe want to add a few more transmitters and utilize also more than one in your position estimation. That would lead to triangulation, where you take relative signal strength. So basically, it's just a calculation based on signal strength of multiple transmitters, and therefore an estimate of the positioning also between them that allows for a much more smooth blue dot animation, for example, because you don't have just those static positions that you had in proximity, but it does not account for obstacles, different wall materials, signal reflections. So typically in a rather sterile environment, this works nice, or in theory, but in reality, we very often, excuse me, we very often face obstacles or something that have an impact on the signal quality throughout the building. And that's where the last principle that I briefly want to explain comes in handy, or tries to tackle that, and that is fingerprinting. You see all those little white dots here laid out over the map. Every single one of those dots is a measurement point of actual signals in that location. So it's a profile basically containing all the signal data that is receivable in that location. And based on those real measurements and the constant comparison of the currently received signal profile with those fingerprints, the position is then estimated. Very, very rough recap. There are on purpose no numbers on this, but just to give you an idea, proximity, very simple, but also not very accurate. Triangulation adds a good portion of accuracy, but also adds some efforts. And fingerprinting gives definitely the best accuracy, but also in comparison, the highest efforts. This seems very high with all those fingerprint measurement points, but we will see later on that it's actually not so bad, and you can set up a fingerprint map fairly easy with the IPS solutions that we support. Which leads me to the first IPS system that is easy to integrate into ArcGIS Indoors, the Apple IPS, which is based on Wi-Fi and supported on Apple devices. It provides comparable accuracy to GPS, what you used outdoors. It provides floor level information, which is crucial, as mentioned before. And as I said, it's Wi-Fi based, and that means that you do not need to roll out any additional hardware in your venue. And the best thing about it is ArcGIS makes Apple positioning really easy. And that's the process behind it. So once you've set up your venue in ArcGIS Indoors, you simply create an export, which is a matter of a few clicks in ArcGIS. You create an IMDF file, which stands for Indoor Mapping Data Format. It's Apple's own format. You upload that to the Apple servers. From there, it's being processed. You get instructions to download a survey application. You go to your venue, you perform a site survey, which is also something that I'm going to explain in more detail with the second IPS, which is our own solution. So I am a bit more knowledgeable how that exactly works. And then those survey recordings are being processed, and within roughly 24 hours, you have a functioning IPS based on the site survey that you conducted, available on Apple devices. Here we have a quick demo of it. You can see this man walking through an Apple store between desks, and you can clearly see that the position, or the blue dot, is following him smoothly as he moves through the store. And as I said, this is without any additional hardware installed in the store, just the existing Wi-Fi. Apple indoor positioning is available on, as I said, Apple devices via either native apps using the Apple Core Location API, or also through websites using Safari on iOS. That leads me to our own IPS solution, which does not only support Apple, but also Android, Bluetooth for both systems, Wi-Fi for Android. So you could theoretically install an Apple IPS for Apple devices and install the indoors IPS for Android devices if you want to go with a setup that works with Wi-Fi only. We typically recommend going for Bluetooth if you want to have the highest possible accuracy. And for that, you would use small transmitters called iBeacons. So what is a beacon? That's a small box. It has a little chip in it and typically a battery. They come in all kinds of shapes, sizes. And we always say they are dumb devices. They don't do much more than sending out a signal with a unique identifier. And based on the signal strength of this transmitter, we can then calculate the position. They typically have a usable range between 10 to 15 meters, but for our use case, we want to narrow that down a little bit because we need strong signal differences in order to calculate the position. So we say roughly 10 to 20 meters. It's important Bluetooth signals are not very robust to obstacles in the way, so we want to avoid that the signal is being disrupted by people walking by. So above head level is a good rule of thumb, like 3 to 4 meters or so. And then you want to have always around 3 beacons available at least in order to get a good signal profile. And again, rule of thumb, highly depending on your venue, is if you have direct line of sight to 3 beacons, you probably have a good signal infrastructure in that spot. Now, with the beacon placement, that depends highly on your kind of venue. So if you have narrow corridors, you can already imagine that you probably need a few more beacons compared to a very open space where you can see a long distance, and the signals can easier distribute throughout the space. So those numbers here are rough estimates, just to give you a brief idea of how much hardware to count with for your venue. Then once you've set up your signal infrastructure, either with beacons or maybe an existing Wi-Fi infrastructure, you will need to create a building map, like with the Apple IPS. It runs on a separate database. You go to our backend, My Indoors, download the measurement tool, and don't worry, it doesn't measure anything. Historically, you would install that on a laptop and run through a venue and measure each fingerprint point. But no worries, nobody has to run around with a laptop anymore. And in order to get your floor plans into that tool, you will run an image export, PNG files from ArcGIS Indoors. So you import your mobile map package, create map exports together with a world file of all those floors that you want to enable for IPS. And together with that world file, you're also getting a georeference, which you will need in order to put the IPS, which generates local coordinates, into the global context and make use of it for ArcGIS Indoors. Once you have both and have done your preparation, it's a simple upload into this measurement tool. You import the floor plans, assign the floor level, assign the georeference and scale, click Save, wait a moment for it to upload and being processed on the server, and you're ready to conduct your site survey. And this process is very similar on our solution as well as on Apple's, which is why I didn't go into much more detail before. In our case, you will download a mobile application for Android. You log in with your credentials, you select your building in your application, load the floor plan, and then you're good to start your site survey. And the site survey is nothing more than just a recording of signal data at known locations. So you would draw a path that you are intending to walk, create waypoints to basically reference the data that you're about to record. And then once you're done drawing your path, you simply walk that path at a normal walking speed. No need to take anything special here into account. As long as you walk like a normal person, you will record enough signal data. And once you've generated recordings for all your buildings or for your spaces overall, you will upload those to a server, start the SLAM process on the server. So our SLAM engine is basically what generates the fingerprints that you've seen on my initial example, just based on those recordings. And that's what I said, what I meant when I said that the process is actually much simpler, and the expected effort is probably similar to what you would have to do for a much simpler triangulation setup. So once the algorithms are done crunching the recordings into fingerprints, you would end up with something that hopefully looks like this. So you can see here multiple buildings on the Esri Redlands campus completely mapped out with fingerprint points, all based on those recordings. So nobody had to stand still in order to generate those points. And as a last step, you will need to enable that for your applications in ArcGIS Pro. You just go to the geoprocessing pane, configure indoor positioning, enter your credentials and so on, hit run, and your application is ready for indoor positioning. And that was it for IPS. Now Pat is going to provide you with some information about our indoors pilot program.
Yep, thanks, Max. So the indoors pilot program is a hands-on engagement with our team to deploy initial operating capabilities for your organization. There's three flavors of the pilot, one without indoor positioning, one with Wi-Fi based positioning, and one with beacon based positioning. We would process up to 10 floor plans in any of the options and conduct an IPS survey for up to nearly 400,000 square feet. And that's the data that we'd bring in. That's the area of the positioning that we'd set up. You could use it for a whole range of use cases. It support, quite a few participants, pilot participants. We'd say between 50 and 100. Device tracking would also be able to be piloted as part of the ArcGIS Indoors pilot, and we would host that in an Esri hosted environment. Alternatively, we could deploy it on-prem if that was a requirement for your organization. Typically, it would take between 10 to 14 weeks to deliver the pilot capabilities to your organization, depending on the choice that you make with IPS or without. Starting with deploying ArcGIS Enterprise environment for indoors, then some data processing, then some IPS setup and configuration, and then on to create maps and applications. And then you'd have 90 days to evaluate indoors with an evaluation license. This is the way to get started. You need to do this to better understand your own data sources, what systems you need to integrate with. Indoor maps, workplace maps are great, but they're better and mean a lot more with connected business information. So the pilot activity is the recommended way to get started to understand the needs of your organization and figure out which groups could benefit the most from these capabilities in a production rollout. And with that, we'll open it up to answering some of the questions that have come in. So Christian, what kind of questions have we gotten?
All right, I got one for you, Pat. Where did it go here? So there was a question about, say you have the app and you want to schedule a meeting with me, but I don't have the app. Can you still share the location information with me?
I could share it with you. And I believe, and I'd have to test this out, I think I've done it before on my mobile device, is it's looking for the indoors application. So you'd wind up being directed to the App Store.
Okay.
To get the indoors application.
Okay. And there was another one. This one might be for Max, actually. So if you are navigating through a building and for some reason the building's data network, the Wi-Fi is not working very well, how does that affect the application? Can you talk to that a little bit?
Yeah, I think for map navigation and so on, Pat can go into way more details. For IPS, I can say IPS works basically completely offline. It's a database that loaded into the building is fairly small, just a few megabytes typically. I mean, the larger the venue, the larger the data set's going to be. But the IPS works entirely offline.
Yeah, and if there was bad connectivity during the initial survey, you would find that out during the survey process. So there's two issues. One is intermittent connectivity issues for your Wi-Fi network, for example, and another would be you just have a bad deployment of Wi-Fi at your organization. And if it's the latter, you're going to find that out quickly at the site survey.
Great, thanks. Got time for a couple more here. Let's see. Here's one about if our floor plans are maintained in CAD, is there a process to automatically push updates from the CAD to GIS, or would we have to maintain two sets of floor plans?
That's a great question. So the indoors tools are standard geoprocessing tools that can be hooked up to any automation, right? So for example, typically when we deploy for customers, we would, we'd have a Python wrapper around the toolbox that we could connect to Windows Task Scheduler, for example, and that would run the tool on any floor plans needing to be updated. And the way that the indoors tool works is it just replaces the floor plans that need to be updated. It doesn't wholesale wipe out or replace everything unless you want it to do that. And typically, in any production environment, you're not going to push these data changes straight to production. This would go to a staging database that would be flagged for QA before you push it to production. I hope that answers the question.
Okay, thanks, Pat. I think we have time for one more. Here's a question about data. So when a user is navigating with indoors, what type of data would be collected from the user other than their location within the environment?
Basically, it's a location and a timestamp. So that's the core data set that you want to have, and you will have an identifier in order to see by whom this data was generated.
Right, and it leverages the Esri location tracking service. So there's two things to consider. One is the blue dot. The blue dot problem is solved on your device. It's not solved on a server somewhere. So there's no master server that's connecting the dots literally between a person's identity and their current location. It's only users that have been preordained to work with the location tracking service. And like Max said, the location tracking service, which is an ArcGIS function that we leverage for indoors, it takes some telemetry data like your heading, your speed, also some device instrumentation stuff like the battery percentage, for example, and it takes the portal username. because it logs that as whoever the editor was, because it actually adds a track to the location tracking service. But that's all organized by your portal admin. So you have to, actively be added to a location track view, for example. And in the application Indoors app, there's also another like you have to positively opt into using it. You have a slider where you can choose to use device tracking or not. And in a current release for this month, you can choose the hours for device tracking that you want to authorize as well. So there's multiple gates for controlling your own, personal information, as well as organizational admin capabilities to set up, location sharing. I hope that answers the question.
Yeah, that's great. Thank you, Pat. With that, I think we're running out of time here. We did receive all the other questions, and we will answer these after the webinar, since some of these seem to be a bit more technical in nature and require a more detailed answer. And as a reminder, this was recorded, and you should be receiving an email from me, Christian Tate, later in this week with the recording, and feel free to ask any more questions you may have in the meantime personally to me. And with that, we want to thank you all for your time today, and we'll see you later.
All right, thank you.
Thank you.
Thank you. Bye.